Hi guys, I'll be doing a series of videos on the AP Calculus BC free response questions. We're going to start off right now talking about the first one. And this is also the year 2014. So let's go to this question somewhere here. Alright. Grass clippings are placed in a bin where they decompose. So that means they're getting fewer and fewer every day. For 0 is less than t is less than 30, the amount of grass clippings remaining in the bin is modeled by A of t equals this exponential. So that's pretty important, so let's just write that down. So A of t, which is the amount of grass clippings for a given time, t, which is in days, is given by 6.687 times 0.931 to the t. Okay? Where A of t is measured in pounds of grass clippings, and t is measured in days. So part A, they wanted us to find the average rate of change, of A of t over the interval from 0 to 30 days. Okay, so A, average rate of change between 0 and 30 days. So you should know by now that an average rate of change, you take the highest, subtract it from the lowest, and divide it by the number of days. Or it's delta A of t over delta t. We're taking the change in A of t, which is the amount of grass clippings, and we're dividing it by the change of time. So delta A of t, so that would be A of 30 minus A of 0, right? Because we end at time equals 30 and we start at time equals 0, and the rate of change of the amount of grass clippings is the amount that you subtract from it, from the highest from the lowest. Alright? And this is over delta t. And delta t goes from 30 and starts from 0. So it's just 30 minus 0, which is 30. Okay, and now this is equal to 6.687 times 0.931. We're just plugging into the equation we have here. And now notice if you plug in 0 to this exponential value, it just cancels out, becomes 1. So then we just get 6.687. And we're dividing all of this by 30. And then if you plug this into the calculator, what you will get is negative 0.197. And notice that it says indicate units of measure. It's very important. So what are our units? Well, they said that A of t is in pounds and the time is in days. So this becomes pounds per day. Okay? That's A. Not too hard. Just the average rate of change over a given time period. So let's go to B. B asks, find the value of A prime of 15 using correct units, interpret the meaning of the value in the context of the problem. So what we want to find is A prime of 15. Now the way to do this, first, of course, we have to find the derivative of A prime. And A prime is just the derivative of A. And this becomes the derivative. And what's A again? A is just 6.687 times 0.931 to the t. Now notice that we're taking the derivative. Forget the constant right now. The constant is 6.687. We're not worrying about this. But we're taking the derivative of something like, for example, 2 to the t. Or should I say, actually, this is not the derivative with respect to x. This is not the derivative with respect to x at all. Because a prime is a derivative with respect to time, not with respect to x. Because you see, this is t, not x, you know. So, let me just change this, not x, but it is instead, rather, time. So let's say we want to take the time derivative of 2 to the t. We know that this is just ln of 2 times the same function to the t. And we can do the same thing here. Okay? So this becomes, we have this constant of 6.687, and now following this guideline, we get the original function times the ln of what's inside, natural log of the inside. So the natural log of the inside is the natural log of 0.931 times the original function, 0.931 to the t. Simple enough. Now, we want a prime of 15. So what we're going to do is we're going to plug it in, 15, into this equation. So we get 6.687 ln of 0.931 times 0.931, and now to the 15. And if you punch this into your calculator, what you would get is negative 0.164. And again, remember the units, pounds per day. And this is equal to a prime of 15. Okay? Let me just draw that a little better. Whatever. Okay, and now this is not the end of the question, because they want us to interpret this meaning. So what does the derivative mean? The derivative is the rate of change, and in this case, we're finding the rate of change of the grass clippings, and this is at time equals 15. So this means that the rate of change, which means the derivative, the rate of change of grass clippings on day number 15, because it's the 15th day, t equals 15, is negative 0.164 pounds. What this is saying is that a prime, you know, is the derivative, the rate of change of the grass clippings, and we're finding at t equals 15, and we found that it's negative 0.164. And you should know that if you get this result, the negative, it makes sense. Because remember, look at the original problem, it says they decompose. So that means every single day is going to be fewer than the next. So this answer actually makes sense. But if you ended up with a positive value, that means that the rate of change is positive. That means that the amount of grass clippings is actually increasing. But that cannot make any sense because they're decomposing, I mean. So that's part B. Now, let's do part C. What does it say? Part C says, find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over this time interval. Okay, so let's make sense out of this. The average amount of grass clippings in the bin. Remember in algebra you were learning about the average of two numbers. Let's say 1 plus 2. What's the average of these? Well, you add them up and you divide them by the number, and that's what you get. In this case, it will be 3/2. But over here it's a little bit different. Since we have a 30-day time period, we don't use this. We're going to we do use this, but not this specific example. We have 30 days of grass clippings to account for. So we're going to sum the sigma from n equals 0, it's the 0th day, to n equals 30. I mean t equals 30. This should be a t, by the way. which is the 30th day. We're summing up all those values as we did here. We're summing up 1 plus 2 plus 3 plus 4, but now we're summing up the grass clippings. We're summing up all of these AFTs, right? Because AFT is the amount of grass clippings that they said was the beginning. And then we divide it by the amount of days, as we did here. Two numbers, we divided by 2. So how many days? It's 30 days, right? So another way to write a sum, you can write a sum as an integral from 0 to 30. 0 to 30. Because we're not going to just add all of these up. We're going to waste all our time. Instead, we can just solve an integral from 0 to 30. And what's AFT? AFT is just 6.687 times 0.931 to the t, dt, over this 30. Now, notice that we can pull out this constant, 6.687 times the integral from 0 to 30 of 0.931 to the t, dt, times, and then we could just do it over 30 here. Now you solve this integral, it's not too hard, or you could just plug it into your calculator, and you get this is approximately equal to 2.753 pounds. Now, this is important because we found that the average amount of grass clippings over this whole time period from 0 to 30 is 2.753. But look at the question. The question asks, find the time t for which the amount of grass clippings in the bin is equal to this. So we have to find out when AFT is equal, when is it equal to 2.753. And now AFT again is just 6.687 0.931 to the t is equal to 2.753. Now we just solve this equation and we're going to find out for time t. So notice we get 0.931, just algebra, equals 2.753 over 6.687. Let me continue my work here. And I'll take the log of both sides. We get t log of 0.931 is equal to log 2.753 over 6.687. And that t is equal to log of this 2.753 over 6.687 divided by log of 0.931. And this comes out when you punch it into your calculator equal to 12.415, and it's time, so it's in days. Okay, now for the last part, let's do it up here, part D. What does part D ask? Part D asks for t equals greater than 30. So this is not in our time interval that we worked with before. L of t, which is the linear approximation to t at time 30, is a better model for the amount of glass clippings. Use L of t to predict the time at which there will be 0.5, half a pound of grass clippings remaining in the bin. So L of t is a linear approximation, and we know that a linear approximation is equal to f of 30 in this case, because they wanted a time equals 30. So f of 30 plus f prime of 30 times 30 minus 0. Actually, this should be t. Actually, it should be t minus 30. Because in general, the linear approximation of something is L of t equals f of a plus f prime of a times t minus a. Or if you have x, it will be the other way around. Instead of x, you would just have t, right? So now we're plugging it in, we get some function for L of t, and we want it to be equal to 0.5. So we get 0.5 is equal to the L of t, the linear approximation about the point t equals 30. So 0.5 equals 0.7829 minus 0.05598 t minus 30. And then when you solve, you get t equals 35.05 days.